Demodulation of SSB waves. Here we are going to see with the help of three different methods, like we have product modulator, balance modulator, and apart from this, third one is the carrier reinsertion. So we'll see here how we can obtain the signals, that is the baseband signals from the received signals. That all we are going to see in detail with the help of circuit diagram and some expressions. So this is the important questions. Before this, already we have discussion about generation. So still, if you didn't subscribe our channel, please subscribe it and share with your friends, write your comments. And if any needs are there, that topic also you can write. So demodulation. Demodulation means we are trying to obtain the baseband signal or message signal from the received signal. So received signal is what here? It is the demodulated signals that we are going. Receive signal is what here? Modulated signals. Okay. So from the modulated signals, we have to obtain the baseband signals. So in this part, if you see that in this circuit diagram, so what are the arrangements are done here, okay, that you can see. So for that purpose, what are things are used here? We have this modulated wave. Input is given here. This is the modulated wave that we call as the S of t. Okay. And here, so now carrier signal is required. So that carrier signal is given here with the help of crystal oscillator. So that if you see that the input side capacitors are used for the coupling, and here output side capacitor is going to use for the blocking. So on the basis of that concept, here input is given. Again, these are the used for the biasing purpose, like voltage divider bias. What we have RD for the transistors. And finally, if you see about the components, okay, so when we have high frequency components and low frequency components, so unwanted signal is being blocked here by the capacitors, resistance, and capacitors. With the help of this combination, unwanted signal is being blocked here, and we are going to get here the desired message signal. So this CC is here coupling capacitor. This CC is also coupling capacitors. Okay. And this is the emitter resistance is the RK. Okay. So this is the arrangements. This part is for the biasing purpose. And here input is given here. So finally here, if you'll notice that in this combination of right side, what we have combination of CF, RF, and again CF is there. So this is going to block the all other signals. So it's going to act as the low pass filters. Okay. So unwanted signals are being blocked here in case of product modulator. Next, we have another is the balanced modulators. So this is another way to obtain the message signal. So here, if you see that SSB input is given here, this is our modulated signals that we have obtained. Okay, that with the help of antenna. Okay, this is the modulated signal. So similar concept is here. So, but the structure is different. Here we are using the diode. Previously we used the transistor. And here crystal oscillator again to give the carrier signals. So two diodes are used here, diode D1 and diode D2. And here we have output left side here, that is the demodulated signal, and the output is obtained. So this one we are going to see with the help of expressions. Okay, in the terms of block diagram. So modulated wave SSB-SC is given to the balance modulator, and here carrier signal is AC dash cos 2 pi FCT. So why we are writing AC dash means in the transmission section where modulation is done, their carrier signal is AC cos 2 pi FCT. So here we are taking the different amplitude. The output of the balance modulator is the SC of T, and finally it is given to the low pass filters. Then we have demodulated signal here. So in terms of expression, if you see that already we have separate lecture for the generation. So there either we can obtain the upper sideband and the lower sideband depend upon your combinations. If you are going to do the subtraction, you'll get the upper side band. If you are going to do the addition, you'll get the lower side band. So here this obtained modulated wave is AC by 2 m of t cos 2 pi f ct minus m cap of t sin 2 pi f ct. So m cap of t is what? Hilbert transform of m of t. So that is the separate lecture. Please go through that. So finally, this output of balanced modulators, one more carrier signal is given here as the input. That is AC dash cos 2 pi f ct. So it is being multiplied here with the received signal, that is the modulated signal, with this AC dash cos 2 pi f ct is being multiplied. So finally, we are going to expand this. So we'll have here cos squared 2 pi f ct, and here outside AC dash by 2. Again, inside we have sine 2 pi f ct cos 2 pi f ct. So now here we are going to apply the trigonometric identities. Okay. So here we are going to multiply and divide by 2. So we'll have expression for the 2 cos square. Okay. 2 cos square theta. So 2 cos square theta is what? 1 plus cos 2 theta. So that here theta value is 2 pi f ct. So on the basis of this, we are getting this expression. And here finally, again, if we multiply and divide, we will have 2 sin A cos B. So 2 sin A cos B formula is what? We have sin A plus B. Okay. And another is the sin A minus B. Okay. Here symbol is the minus symbol. So finally here, in this case, this is the plus here. Okay. So finally, what will happen here? 2 pi f ct and 2 pi f ct. So it is being added here. So we'll have 4 pi f ct, and here it is being cancelled. So sine 0 value is what? 0. So that's why only one term we are getting here, sine 2 pi f ct into 2. Okay. So it's becoming 4 pi f ct. So further again, we are going to segregate these parts. So we have three terms. So first term having only modulator, that is the message signal, baseband signal components, whereas the remaining two having carrier signal components also. So our desired signal is what here? Only first term. So this first term only should allow to pass through this low pass filter. So that's why you are saying that here message signal doesn't have any carrier signals, and carrier frequency, you know that it is always much higher in compared to message frequency. Okay. So that's why here low pass filter is used. So low pass filter means it will allow only low frequency component to pass. It will block this high frequency components. So again, this one you can see here in terms of a spectrum of that one. Okay. So this is the bandwidth minus W to W. This is for the baseband signals. And here we have upper side band 2fc to f2fc plus W. So bandwidth is the W. Again here left side. So this is the spectrum in case of balanced modulator, how we are going to use here. So high frequency component is stopped here, and the local oscillators of the receiver in, it should be must be identical in terms of generation. So that's why synchronization is required. So that is the same frequency should be there of the carrier signal in the transmitter side as well as receiver sides. And here we have two different condition is possible. If there is non-identical frequency and phase, then it will rise the distortion in the demodulated signals. So we have two different conditions. If del f is not equal to 0, then phase shift is equal to 0. Okay, if del f equal to 0, then phase shift is not equal to 0. So like this condition we have in case of non-identical. Third method is what? Carrier reinsertion technique or phase shift networks. So name itself is the carrier reinsertion, means carrier will be inserted here. Okay. So again, here what is the requirement? Perfectly synchronized oscillator is being used here. And we have modulated wave m of t into cos 2 pi f ct minus m cap of t sin 2 pi f ct. So carrier signal is considered here AC cos 2 pi f ct. So that is being added with the modulated wave. So we have S naught of t combination of the carrier signal along with the modulated wave. Okay. So now here common term is taken here. So that is the common part in the first two term is the AC, that is the cos 2 pi f ct. Okay. So from the first term we are getting AC, from second term m of t. So that's why here we have AC plus m of t, and third term is written as it is. And finally, this equation 4, we can write E of t into cos 2 pi ct plus theta. So now we are going to see that what is the value of E of t and how we can obtain with the help of envelope. So E of t is here, root under AC plus m of t whole square plus m cap of t square. So this is the expression. Okay, this is the one components like you are able to find in case of x plus minus jy. So that magnitude is what? X square plus y square. And angle is what? Theta is tan inverse y by x. So similar concept is used here also. Okay. So on the basis of that, this is the E of t and this is theta value, tan inverse m cap of t divided by AC plus m of t. So this E of t is what? That is the envelope. So you know about this amplitude modulation, what is the envelope and how it is going to work. So now we are going to expand that envelope component AC plus m of t whole square. So this is a plus b whole square. So a square plus b square plus 2ab, and this term is kept as it is. Now AC is taken as the common, so remaining term is divided by AC where this component is not available. Okay, so here AC square is taken common. So AC square root is what? AC. So outside the square root, it is AC. And this term is divided by AC square. Here already one AC is there. So divided by AC. Here no AC is available. So it is divided by AC square. So now we are going to take some approximate value. If AC is much greater than m of t, no modulus, that means AC is much greater than amplitude of this message signal. So in that case, what we'll see, you are dividing by the higher values. So when you are dividing by the higher values, so this term is going to be approx very less. Again, this term is going to become approx very less. So finally, we have E of t approximately equal to AC into 1 plus 2m of t by AC, a square root, that is the 1 by 2 is written. Again, if you see by the help of binomial expansion, if this part is going to be a small, so we can write that is the AC plus that is 2m of t by AC. So finally, if you'll expand this one, so here AC is outside. So what we'll have 1 plus m of t by AC, and this 2 is here. So by the help of binomial expansion, so this 2 will get cancelled. So finally you will expand. So we'll have AC plus m of t. So this is the approximate value what we have obtained. So now we have E of t value is AC plus m of t. So that we can substitute in the previous equation where we have started first time E of t. So now S of t is AC plus m of t cos 2 pi f c plus theta. So finally, what we are seeing that here, one is the message signal components, another is the carrier signals. So when we have large carriers, the envelope of S of t form the baseband signals M of t, and it can be detected by using the envelope detector. So already we have seen the discussion how envelope detector is going to work. Okay. So this is all discussion about demodulation of SSB-SC signals by 3 different methods. So in exam, any one method is going to ask. So that particular method you need to explain. No need to explain all. Suppose they're asking about carrier re-insertion, go for carrier re-insertion. If they're asking about balanced modulator, go for balanced modulator. So most important is the carrier re-insertion and balanced modulator. Thank you. Thank you very much. Like, share, subscribe. Thank you.